which we have repeated. Then we come and we add, that is it. Now the drop. When you add a drop, the man has said 3 drops. But even if you use 1 drop, it can what? It can work. There we go. Now I've used the 2 drops. Then I add the 3rd drop if I want. But following the procedure they have said, there I add the 3rd one. You can see now the solution is turning to pink. Now after doing that, the man is saying titrate with the BA2 from where? Titrate with the BA2 from the burette until the color changes. Titrating means we are going to allow the liquid in the burette to drop into the liquid we have pipetted. So what are we going to do? We are going to get our BA2. This is our BA2 here. We get our BA2. Then we get a funnel. This is our funnel. Then we transfer the BA2 into our burette. Now this burette, if it is very far, you can reduce a bit by adjusting the clip here like that. Then you pour the liquid in the what? In the burette. So there we go. We put our liquid in our burette like that. Now what happens? You pour the liquid until it reaches 0 mark. So we have a 0 mark here, don't forget it. There is a 0 mark here. Follow up that 0 mark. You can see that our liquid is above the 0 mark. What happens next? You open the tap down. We are going to open the tap down here. So we open our tap a bit like that to release some liquid. When you open the tap, you release the liquid a bit like that. Open the tap, then you release the liquid. As you are releasing the liquid, the 0 mark will be reached. You can see our liquid is going down, going down, going down. And when we reach our 0, that point there, we are taking readings of the burette. We prefer this point here where the liquid is curving. Are you seeing this line? This point here, the figure which is here, matching with the curve of the liquid is what we are taking. Not this point here or this point here. This point will be wrong. It will be as a result of reflection. But here now is the right point where the liquid. This point here, not the point which you are seeing up. Now, after putting my BA2 in my burette, remember the procedure here was saying titrate. Procedure was saying do what? Titrate with BA2 from where? From the burette. We have already put our BA2 in the burette. Now we want to obey the issue of titrating. When we are going to titrate, the only thing we are going to do, members, we are going to carry the liquid which we pipetted, the liquid which is pipetted, and we added an indicator. Then we are going to put it below the tap. We are going to put it below the tap. Let me try to elevate a bit my burette. Now I'm putting below the tap. After putting it there, I'm going to open the other procedure. The next procedure was saying we titrate until the color does what? Change. We are saying that one implies that you bring the other solution which you pipetted with the indicator, then you put the solution, you put the solution below the tap. Putting the solution below the tap, you make sure that the hand you use, if you are a writer, if you are using right hand side, you hold the tap with the right hand side. If you are a lefter, use the left hand side. So I hold my tap like that, then I open my tap. I hold my tap, then I open it like that. I want to open my tap as I'm doing some thorough shaking here. And as you are shaking, you make sure that you don't break the tap, or you don't break even the conical what? The conical flask. Here we go. I continue adding as I'm shaking, but you have to apply all the senses here so that you don't do some breaking and you don't lose the color change. Remember, we are going to add until when the pink begins to disappear. You can see that the intensity is reducing a bit. When you see that the intensity is beginning to reduce, then you begin adding a drop by what? By drop. So there we go. We continue adding like that. You can see the intensity as I'm adding my substance from the burette, the color keeps on reducing, like that. So you continue adding. So I make sure my eyes are keen here. There we go now. You can see that the color, when you check properly, the color, all of the color is what? Is now over. However, we are saying it should not be clear like this. This one was the beginning experiment. Now I'm going to show you, this one was a rough experiment. What we are calling rough experiment. I'm going to show you the experiment which is what? Exact now. Now members, after the other color changing, we come and read our burette now. When you are reading the burette, we said we read the meniscus. When you look at our meniscus here, the meniscus is exactly at 12. Meaning my reading here is going to be 12. So what am I going to do? I transfer the 12 from here, I put it here now, where it is the final burette reading. But remember, before you write here, the pipette which you used here, the pipette which you used, the figure which is here on your pipette must be written here. So you come here, this one is 25, I put here 20 what? 25 point what? 0.0. It is read at 1 decimal what? Place. If it is 20, I write there 20. Now after writing it like that, I come and then I put the other figure which I have got. My figure was 12. That is 12.00. When we are filling here, I'm putting 0.00. When you are filling this table, we make sure that on our right hand side here, take a note, this is our right hand what? Side. We put it 2 decimal places. If it was 13, I would write 13.00. If it was 12.1, assuming it was 12.1, there I would say 12.10. Even if it was 5 point maybe 2, I don't write like this here. I make sure I add a 0 here to make it 5.20. Take a note of that. Once you don't put 2 decimal places on your right hand side, I mean this is my right hand side here, the figure becomes wrong and the whole table will become wrong. However, there is a space which you are going to fill here. Initial. This initial means the beginning point. What was our beginning point here when we are filling our burette? Our beginning point here, it was 0. This is our initial, where we came from. So we come and put here 0. Remember 2 decimal places on your right hand side, 0.00. Now after putting 0.00, now we are going to get the value here. How do we get the value here? You get this value, the final burette reading, minus the initial burette reading. So we are going to get 12.00 minus 0.00. And obviously, we are going to obtain here 12.00. Take a note of that. Now, after doing that, what do? We get this solution, then we pour it away. Then we wash, we get this one, our resultant after titrating. Then we wash our conical flask. We pour and we wash. Now after completing this one, now we repeat the same procedure. What was the beginning point? Pipette. I get my pipette here, as you are seeing. I get my pipette. Now I'm going to put it in the BA1. I do the same way as I did. I pipette. That. Remember pipetting, you suck with the mouth. Then don't forget the other line which you talked about here. Then you open up your finger here. You open up your finger, thumb finger here, to release some. There we go, we release. Then we hold like that. After doing that, we transfer into our clean conical flask. We may even blow some air to increase the speed and remove everything. Now we have got our solution. Now we are pipetted. After pipetting, the second procedure was we add drops of what? Phenolphthalein. Then what do? We add our drops of phenolphthalein, like that. I add the first, like that. I add the second, like that. Add the third. The man was saying 3 drops. Now I have my 3 drops, and this is my resultant solution. What happens next? I come back here to titrate again. But when I'm going to titrate, remember now I ended at 12. This one is going to work as my initial. Here I have 2 options. I may fill it again to 0 if I want. But if I don't want to fill it back to 0, where I have stopped here, it becomes my initial. So I can make my initial to be 12. Where I have ended here, this one can become my initial. If I do what I want, so I ended at 12, meaning I'm going to begin at 12 there as my initial. However, if I want, I can fill it back here. If you have a reagent enough, I fill it back. Now, I'm beginning from 12. What happens next? I'm going to titrate now. Titrating, we said what? You hold the tap like that. Holding the tap, then you open up the tap like that. Turn up the tap. Turn up the tap properly as you are shaking. As you are shaking. Remember, we don't want the oil. Remember, we don't want the oil color to go away. Our target is to make it beginning to do what? To turn. So I continue adding. The more I'm adding, you'll discover that the color, which is pink, is reducing. So you have to be careful there as you are adding. So there we can add a drop by drop, drop by drop, drop by drop, as we are shaking. Don't forget that. Drop by drop. Then I can see my solution is almost now changing. So you have to be careful here. Remember the first one I told you it was a rough experiment. Rough experiment. So you can see that our pink is almost going away. So you have to be careful if you want to get correct results. Correct results now. Our pink is still there, but you can see that it's going away. So drop by drop now. Let me add more a drop again. I check what is happening. That is a drop. Another drop. So now, members, we are saying that our solution should be, the pink should not disappear. So, but it should be at the point where it begins to do what? To change. So I put another drop like that. You can see now it is beginning to turn. I add another one. I should not go away completely. It should be like that pink when it begins to disappear. That will be the base end point. Not at the point like the other one where all of it is what? Is clear. So after doing that, then we come and take a note of our recording. Take a note of our recording. When we take note of our recording here, our beginning point was 12. As we wrote here, 12. Then now we are seeing that our ending point is 23.9. So what do? We take this reading of the rate here of 23.9 here. We take it to our table here. So we have 23.90. Then we get this one minus that to obtain the lower value, which is going to be 11.90. Then after doing that, we pour this mixture we have in our conical flask here. This mixture, we pour it. We wash. Then we pipette again. We add the indicator again. Then we titrate again. That's what we are going to do. Then after doing it, then we fill our table again. Now members, after filling our table like that, this was the first experiment, remember? This one was the second experiment, and this one is our third experiment. Now we are going to pick the values which are called values to calculate average theta. It was values to calculate here, to calculate average theta. Now our values to calculate average theta, we pick the values which are similar or near each other. If they are different, they should be in the range of, for example, if they are different, they should be in the range of like minus or plus 0.1, 0.2, 0.3, 0.4, or 0.5. But take an example here. We're going to pick this one and this one. They are near each other. We have 11.90 and 11.80. Why am I picking this one and this one? When you look at them, they are almost the same. The difference is going to be 0.1. So these values, as I'm saying, if they are different, they should be different in the range of 0.1 up to 0.5. This one is plus or minus. What am I meaning? You can either, your value can be lower than by 0.1, or it can be lower than by 0.2, or lower than by 0.3, or lower than by 0.4 or 0.5, or it may be higher than by 0.1 or 0.2, and so on. Now after picking our values here from our table, these are the values we have picked. Now we are going to get the average theta. How are we getting the average theta? We are going to only add up the figures. We shall get our 11.90 plus our 11.80. Then we divide by 2. In simple terms, we are getting the mean in mathematics, average. Then when we sum up our values on my calculator now, when I get my calculator here, I'm obtaining an average of 11.85 cubic what? Cubic centimeter. This one is going to act as our theta what? Our theta value, which we are going to use in our calculation. Now members, even 12, when you look at the 12, even 12 was okay. If we are taking the 3 figures, we can even take the 12, because even when you look at 12, the difference between 12 and this is almost in this range. Even the difference between 12 and this is falling in this range. But why am I picking this one and this one? For me, I've taken this one because they are mathematically close to each other. And when you look at the values they want here, they want 1, 2. So there is no way we can pick this one, pick this, pick this. So if you want, you can pick this and this. You can even pick this and the other. But for me, it was my choice to take these ones. But you can even take this and this. Or you take this one, the other one. It depends on your choice. Then, if you add 3 spaces here, 1, 2, 3. We are taking all of the 3 values. There we shall get 12.00 plus 11.90, then plus 11.80. Then you divide by 3. Take note of this. Here I'm dividing by 3 because I've picked 3 values. Here I've divided by 2 because I picked only 2 values. Don't forget that. Don't pick 2 and divide by 3. Or you pick 3 and you divide by 2. Then from there, we come to our question here. They are saying, calculate the moles of sulfuric what? Sulfuric acid. We are going to find moles of sulfuric acid. If you are going to find our solution for our question, let us first consider Roman 1, moles of sulfuric acid. Moles of sulfuric acid. This one we are just going to begin by saying, remember our molarity of the acid was 0.1 molar and our theta value was 11.85 cubic centimeters. So what we are going to say, we are just going to say this one is in 1,000. This one means molarity. So we say 1,000 cubic centimeters of the solution contain the 0.1 moles of sulfuric acid. Then we say what about 1 cubic centimeter of the same solution. This one contains, I'll say contains, we shall cross multiply this one times this one here. So we shall say 1 times 0.1 divided by this one, 1,000, over 1,000. And here we shall get now moles of sulfuric what? Sulfuric acid. After doing that, then we see what about our titer value we got from the table, our average. We got from the table, don't forget. So our table, we got our average was 11.8, 5 cubic centimeters. Now we see this one of the same solution, contains, we are going to cross multiply still. We are going to multiply this time the other one, so we shall get 11.85 times 0.1 over 1,000. And this one is a 0 moles of the acid, that is sulfuric acid. So now when we get our calculator, we are going to obtain 0.0001185 moles of sulfuric what? Sulfuric acid. Now after obtaining those ones, what is next here? They are saying we find moles of sodium hydroxide. So Roman 2, we are finding moles of sodium hydroxide. Now to find moles for sodium hydroxide, we are going to begin by writing. We'll write our equation here. We shall get sodium hydroxide here, solution, plus sulfuric acid, plus our sulfuric acid here is also aqueous, and here we are going to obtain our sodium sulfate plus water there. Then we can balance the equation by putting the 2 here. The essence of writing the equation is to obtain what we call a molar ratio. Remember, molar ratio, as we said, that we get it from the numbers in front. So here we have now 2 here, and it is a hidden 1 here, don't forget. So the molar ratio is going to become 2 to 1. This implies that 1 mole of sulfuric acid, reacts with 2 moles of sodium hydroxide, like that. Sodium hydroxide. Then what about the other moles which we got? The moles here. The 0, we have the 0.001185 moles reacts with how many moles? So directly cross multiply this one times this, so we get 0.001185 times 2 out of 1, and then we are going to obtain our answer 0.00. When you get your calculator, 237 moles of sodium hydroxide, and those are the moles needed. Now from there, the third Roman, they are saying molarity of sodium hydroxide. These are moles in 1,000. So here we are going to say Roman 3, molarity of sodium hydroxide. What are we going to do? Now these moles we have got here, they are in the pipette we use. Remember our pipette was of 25 cubic centimeters. Don't forget the figure which was on the pipette. So what are we going to say? We are going to say 25 cubic centimeters of the solution contain. Now this one is containing the 0.00237 moles of sodium hydroxide. Then what about 1,000 cubic centimeters of the solution, the same solution now. So the solution contain, so we are going to cross multiply still. We shall get 1,000 times 0.00237 divided by our 20 what? Our 25. These are moles now, don't forget. Moles of sodium hydroxide now in 1,000. And our value here, which we are going to, after multiplying there, we are obtaining 0.09 molar. Or you can even call these ones moles per what? Per liter. Per liter, remember you can even write per liter like this. So now our 0.09 molar, we can even say moles per liter. Moles per liter. Like that. Or you can even say moles per decimeter cubed. And after getting our molarity, this is our molarity, we can compute now Roman 4. Our Roman 4 is saying concentration in grams per liter. So we are going to say molarity is just equivalent the concentration in grams per liter over molar mass. Over molar mass. Therefore, you have to find the molar mass of sodium hydroxide. Molar mass of sodium hydroxide will be now, we are just going to get 23 as sodium is appearing in periodic table, then plus 16 times 1, then plus 1 times 1. Those are relative atomic masses of the elements as they appear in the periodic table. This one is going to give us 40 grams. Then from there we substitute there. As we are substituting, we are going to make concentration in grams per liter the subject. So our concentration in grams per liter is equivalent to the molarity, which you have already calculated above, then times the molar mass. Our molar mass, now our molarity has been 0.09 times the molar mass, which is 40. And here we are going to obtain, when you get a calculator, 3.6 grams per liter. And this one will be our concentration, which is the question what? Concentration in grams per liter. Concentration in grams per liter is the same as mass. Don't forget that. That is the same as mass.